One of the toughest things to understand in the world of physics is electricity. You can't see it. I'm going to help you understand the difference between charge, current and voltage. So let's get on and demystify electricity. I'm going to avoid the maths, but don't worry, if you want to see the maths and some examples, take a look at my YouTube shorts. I'll place some links in the description below. But don't go anywhere just yet. Let's get started with a straightforward circuit. Here's a cell with a lamp. When the circuit is complete, in other words there's no gaps to stop the electricity flowing, then the lamp will be on. Something must be moving from the cell to the lamp. That something is energy. But how does energy move round the circuit? A simple way to think of it is that energy takes a ride on the back of electrical charges, and it's the charges that are actually moving round the circuit. That's it. Well, not quite, don't stop watching. But put simply, electricity is just the movement of charge, and that charge carries energy. In a wire, it is electrons that move, and we say those electrons are the charge carriers. The current in a circuit always flows from positive to negative, and that was decided well before we discovered electrons, which we now know are negative. Electrons are therefore repelled by the negative and attracted to the positive. So confusingly, electric current flows in the opposite direction to the electrons. And now it's just too late for us all to change it. It's not just wires in circuits that conduct electricity. In pure water and other solutions can conduct electricity too. When they conduct, it is ions that are moving as the charge carriers and not electrons. Ions could be positive or negative. So what is this current thing that people talk about? Well, electric current is just the amount of charge that is flowing per second. Think of it like cars passing by. The cars are like the charges. The current is just the number of cars, or the number of charges, that are passing every second. So the greater the current, the more charge is passing every second. Considering that the charge carries energy, there's also more energy passing every second. A high current can therefore cause things to get hot. Too high a current can cause wires and appliances to melt and can cause a fire. Consider this when you start plugging lots of things into a socket. If you draw too much current from that socket, things will go wrong. Another way to increase the energy being carried around a circuit is to increase the voltage supplied. This is a cell, it supplies 1.5 volts. This is a battery, it supplies 6 volts. A battery is just more than one cell. This is a battery that supplies 12 volts. It's made up of lots of cells inside. So what do we mean by voltage? The voltage tells us the energy being given to each charge. 1 volt is 1 joule of energy for every 1 coulomb of charge. This is a 12 volt lamp. It will take 12 joules of energy for every coulomb of charge that passes if it's to work properly. This circuit shows 12 volts being supplied by the cell and 12 volts being taken away by the lamp. We often call the voltage the potential difference. This is because there is a difference in the potential of the charges between 2 points. Here, the charge has the potential to give 12 joules of energy. Here, the charge has given up its 12 joules of energy and has a potential of 0. We therefore say there is a potential difference of 12 volts between these 2 points. So where are we at? Electricity is all about charge. Current is the amount of charge passing every second, and voltage is the amount of energy being carried by each charge as it passes. This means if we increase either the current or the voltage, then we increase the amount of energy that the current is supplying every second, and therefore increase the power. A funny thing though, charge has the symbol Q, current has the symbol I, and potential difference has the symbol V. Why Q and I?
Just a French who suggested electrical quantity and electrical intensity. I told you I can't do flipping accent.
If you found this useful or interesting, please like and subscribe to encourage me to make more. Remember, I've also made some shorts about using the equations. You can find those on my channel or in the description below. And if you want to learn more, it's a good idea to watch this video. Thank you for watching. See you next time. Bye bye.